In lesson 3, we're going to continue talking about congruent triangles and talking about how to use transformations to be sure that two triangles are congruent. So in this activity 3.1, we're going to be taking a look at a congruent statement here. Triangle ABC is congruent to triangle A prime, B prime, C prime through a transformation. Since it's the prime notation, we know that this is the image of ABC. So we want to go ahead and decide what stuff is true, what is sometimes true, and what's not true at all based on a statement. So what kinds of things can we determine are all the time true, sometimes true, or possibly true, and things that are just not true at all. So go ahead, take that list, think of all the things that you can put into each of these categories, write as many down as you can, and then pause the video while you're doing that and come back to hear what I say. So some things that you might come up with that are completely true, since we know that this is the original figure and the image, we would know that corresponding parts are going to be congruent. So we would know that angle A is equal to angle A prime. Similarly, angle B would be equal to angle B prime, and angle C would be equal to angle C prime. We would also know that the sides are congruent, the segment images are congruent. So AB is going to be congruent to A prime, B prime. BC is going to be equal to B prime, C prime. AC is going to be equal to A prime, C prime as well. So you could kind of get all of those things listed out of the corresponding parts. You could say some things like, we know each shape has 3 sides and angles. You could have said maybe that you know that angle A plus B plus C equals 180, which doesn't have anything to do with whether, these two don't have anything to do with whether or not the two shapes are congruent, but they are things that you definitely know about the two figures. You would maybe even know from them being congruent that there's some type of rigid motion. Okay, so, there is a rigid motion that takes ABC to A prime, B prime, C prime. Okay, so we know because they're congruent that for sure happens, that there's a rigid motion that would take them onto one another. So what, and you may have come up with more. So how about some things that are maybe true? So what might be true here? So anything like very specific about the triangles. So maybe like you're saying what type of triangle it is. So triangle ABC is, maybe you're saying acute. Okay. Now this could be any of the other types as well. Fill in scalene, isosceles, right, obtuse, equilateral, equiangular. I mean, any of these, if you said any of these about the triangle, that would be incorrect. Okay, I mean, it's not necessarily false, but it's not true. We don't know for sure. So if you're saying anything very specific about the triangles, okay, another thing maybe you said is something specific about the translation or the transformation. So and you said translation takes ABC onto A prime, B prime, C prime. Okay, or maybe you said a translation and a rotation, or followed by a rotation, takes ABC onto A prime, B prime, C prime. So this specific language about what type of rigid motion, we don't know that. Okay, we don't know if it's a translation, if it's a rotation, a reflection, or any combo of those. Okay, so we have no idea about that. So what things are definitely not true? So things that would mean that these aren't equal. We know A and A prime are equal, B and B prime, and so on. So if you said angle A is less than angle A prime, that certainly cannot happen. Okay, or something about the sides. BC is not equal to B prime, C prime. So we know that they are equal, so they can't not be equal. Or you could say less than or greater than in here too. We certainly know that A plus B plus C can't be greater than 180, okay? Or it can't be less than 180 because it has to be equal to 180. So if you wanted to do something with the triangle sum theorem, you certainly could have said something there. We know that triangle ABC can't have 4 sides, okay? This number right here can't be anything but 3, okay? So if you put 5, 6, 7, that certainly can't happen. A triangle only has 3 sides. So those are some things that maybe you came up with that were not true, okay? That can never be true. So then in this next activity, we're going to practice with instructions on doing transformations to get one congruent triangle onto the next. So when we know that all of their parts are equal, let's take a look at transformations to make sure that we know that those triangles' parts are going to be equal, okay, and that they'll land on top of each other. So we've talked about this before where we have the instructions for if you're going to do a translation. We would translate point something to another point. So translate point A to point D. Rotate around a figure. Okay, so rotate this figure around what point until what point coincides with another point. So for instance, rotate triangle ABC around point C until A lands on E. So you say what the figure is here, okay, what point is staying, and what point is moving on to another point. And if you're doing a reflection, you need to name a line. So reflect over line AB or reflect across line PQ, something like that. So that's the language that you're going to be using or that you would have used in this, what you're going to use in this activity. So let's take a look at, and I'm going to do one example with you right here. So if this was the card that you had, okay, and this is what you're looking at, we want to use language to see to move this triangle JKL over onto this one. And we can see that all of the corresponding parts are the same, okay? So we see that angle J, I'm just going to write these out. We see that angle J is congruent to angle P. We see the arc with 1 tick in each of those. We see that angle L is congruent to angle R. We see that angle K is congruent to angle Q. Then we see tick marks on these sides, so we see that side JL or segment JL is equal to PR. We see that LK is equal to, that has 2 tick marks, so QR. And then that JK is congruent to or equal to PQ. Okay, so we see this marked up on these pictures. So now let's take a look at transformations that could bring one triangle to the next. So in this case, they're not touching each other. No vertices are matching. So I'm going to first do a translation to get at least one of the vertices matching. So I'm going to match J to P. So I'm going to say translate point J to point P. So then I'm just going to pick up this triangle. So if you had tracing paper, you would just move it over so that J landed on P. And you're going to be doing this in partners. So one partner is going to be saying the language and the other partner is going to be using tracing paper. Okay, so if I were saying translate point J to P, my partner would pick up the tracing paper and move J onto P. Okay, then I would see it did this. Then I would say, okay, so I need to tell them something else to do because it hasn't landed yet. So what I would like to do then is I would like to match K up with its equal angle. So I would like to move K to Q. So I'm going to rotate the triangle. So I'm going to ask my partner to rotate triangle JLK around point J because I want this to stay. Okay, so I want this one to stay put until K coincides with Q. So until K hits Q, then I want them to stop. So now my partner would hold point J in place and then rotate the triangle until K lands exactly on Q, and then they would stop. Okay, so then my partner has done this. Now I see that I've got J on P and I've got K on Q. And then I see that it's not all the way lined up yet. So this triangle still needs L to flip down to R. So that's a reflection. So now I'm just going to reflect this triangle across this line. You can call it JK or PQ, whichever you want. I'm going to call it PQ. So then that would flip this over and that would land L right on top of R. So flipping it over, whoops. So flipping it would then end up like that, where it would just land exactly on that other triangle. So you can tell that these are the same size. So we see that they landed exactly on each other, and I just followed this set of instructions. Now, not everyone is going to take all three. Some might just take one. Maybe they're going to take two. It just depends. So if you're the one giving instructions, watch as your partner moves the tracing paper over to see if your instructions have landed one triangle exactly on top of the other, or if you need to keep saying more transformations. So once you've done that, then you can, or pause the video, and then once you've done that, you can come back and I'll talk through each of those. So the different cards that were there looked like this. So let's take a look at each card and what instructions moved one shape onto the other. So for card A, if we just translated point A to point D, it actually moved the entire triangle over and landed exactly on it. So this one only required a translation from point A to D, and then the whole shape moved, okay? Or the whole shape landed onto all the vertices matched up, all the corresponding parts matched up. Card B, okay, so if we translate, now remember, translate a corresponding part. So if I'm gonna move, like, I wanna move C to F, okay, so I see that C only has an angle with one arc, and so does F. So I'm gonna translate C to F, and that didn't move it fully on there. So far we've done translate C to F. Let me type this instead. Okay, so translate point C to point F, and that got us here. So now it looks like I'm gonna need to rotate. Okay, and remember this point right here is B, so now I'm gonna rotate. And I'm going to rotate triangle ABC around point F until, and you can pick what you want. Do you want A to land on E or D to land on B, whichever you want. B to land on D. So I'm going to do until point B lands on point D. So then you just take and rotate this, keeping F in the same spot. Okay. Oh, and I said that wrong. Not B. B doesn't want to land on D because B has 2 marks and D has 3. So I would like for B to land on E. Okay, so I'm going to keep rotating this until B lands on E, keeping F in the same spot. So then once B lands on E, we see that actually all the parts are in line. Okay, that triangle landed on triangle ABC, fully landed on triangle DEF. So then we can stop. That one took 2 transformations, translate and rotate. So then we'll take a look at this third one. Okay, and this third one. So first, again, they're not touching, so I'm going to move 1 point onto its corresponding part. So I'm going to take A and move it to D. Okay, so translate point A to point D. And then B matches with E, so now I'm going to rotate ABC, so triangle ABC, around point D, the one that's already matched up. until point B coincides or lands on with point E. So I'm going to rotate this until B lands on E, keeping D in the same spot. Okay, so then we got those to match up. And we know AB is the same length as DE because we see that tick mark. So we know that it landed right there. And then now we just need to reflect. So reflect over, and you could say reflect ABC, triangle ABC over segment DE. And then once you reflect that over, so let's see if I can reflect this. So reflect it over, whoops. I don't know if we'll be able to reflect this. Nope. Okay, so I can't really reflect it, but if you reflect it over, then it will land directly on F, okay, and you'll have that translated. So something similar to that is what you should have come up with in your groups. And then you have one more set of cards to try to do this again. So try your second set, and then I'll talk you through it. Okay, so taking a look at these, and this time I'm not going to type them out, I'm just going to talk through them. But this first card would just be a translation, so translate point L to Q, and it would have landed exactly on there. Second card, translate, and again, any one of these, so let me just do L to Q again. So translate L to Q, then rotate, and now this is point K. Point K goes with P, so I'm going to rotate triangle LKM around point Q until K lands on M. So until K lands on its corresponding or congruent angle. So until it lands on M. And once that happens, then the triangles are directly on top of each other. Okay, so this one took a translation and a rotation. This one, I'm going to translate K to P so that it fits on my screen. Okay, so K to P, and then I'm going to rotate L, this one's L, to Q. Okay, so I'm going to rotate around point P, so keep point P the same. Whoops, until L lands on Q. Okay, and remember L is this right angle point right here. Okay, so keeping P in the same spot until L lands on Q. And then the final thing that you would need to do in this one would be a reflection over PQ. So this is what you're supposed to get from this. Whoops, let's go to the summary. So what you're supposed to kind of understand from this is that if all corresponding parts of two triangles, okay, so we had all the corresponding parts were equal. So if we know that, okay, then one of the triangles can be taken exactly to the other using a sequence of translations, rotations, and reflections, okay? So using a sequence of those, which means just one or more. Okay, so we did one that just went translation, a couple that did translation, rotation, a couple that used all three. So one of the most common ways to do this, and because you can do it a bunch of different ways, but the way that I just talked through it is one of the most common ways, okay, is line up the vertices through a translation. So get one of the vertices to land on its partner, okay, then rotate it to get a second pair of vertices to line up, okay, and maybe maybe the translation will line up all three. Maybe after the rotation, all three will be lined up. So if needed, you can do the reflection. So when we did these, the translation here landed it, right? So we just had to do a translation. Here, we had to do a translation and a rotation. Here, we had to do a translation, a rotation to get 2, and a reflection to get 3. Okay, so some combo of those will always get your corresponding parts as long as they're congruent to line up. And then you can see some more specifics in the lesson summary that's printed in your book. Okay, it again talks through kind of what I just said there, where we talk about the different kind of translations. You can translate, you can rotate, you can reflect. Okay, talks through doing that. And then you can see a diagram here, lining up D, rotating to get E, and then reflecting to get C if we need to. And then here's the cool down. So taking this picture that has all of this stuff labeled for you, okay, it tells you 2 congruent sides, okay, it tells you 1 set of congruent angles right here, and also BC is the same in each triangle. So write a rigid transformation that will take GBC onto triangle ABC. Explain why G prime, okay, why will G prime land on A? And is triangle GBC congruent to triangle ABC? Explain your reasoning.